All right, guys, let's look at these U-tries. So in order to find the median of the first U-try, I put all the numbers in order. There are 8 data sets here, and my middle 2 data sets were 54 and 68. I added those together and divided by 2 to find their average, and so their middle number was 61, and that became our median of this data set. The mode was 90 because 90 appeared 2 times in the data set. 90 and 90. And then when I added all 8 terms together, so all 8 data sets were added together and divided by 8, we received 477 divided by 8, which rounded up to 59.6. If you wrote out the whole 59.625, that would also be correct because that does have a terminating decimal. All right, and then let's go to the second U-try. We had 6 terms here. So when I put them in numerical order from least to greatest, we had 12, 12, 15, 24, 31, and 38. Their middle 2 terms were 15 and 24, so I found the average of those 2, and that gave us a median of 19.5. Our mode was 12 because it was repeated, and when I added all of my data sets together and divided by 6, I wound up with a mean or average of 22. All right, so let's move on to a little bit newer concept, and that is our mean absolute deviation. So what is it? Our mean absolute deviation is the average distance between each data value and the mean. So the MAD helps us get a sense of how close the values in data are. So example 1, given the data set 9, 4, 36, 3, 10, 6, 8. We need to find the mean absolute deviation. So our first step is to find the mean. Well, I'm going to say 9 plus 4 plus 36 plus 3 plus 10 plus 6 plus 8. And that is 1, 2, 3, 4, 5, 6, 7 terms. So I'm going to divide that sum by 7. So in my calculator, I've got 9 plus 4 plus 36 plus 3 plus 10 plus 6 plus 8. And dividing the whole sum by 7. That gives us 76 divided by 7, which is approximately 10.9. So our mean is 10.9. Now we're going to use the clock method. We're going to place the mean in the middle of the circle. So you'll see like this X bar, this is your mean, and find the distance to each number. There will be no negative numbers. So if our mean is greater than whatever data set we were looking at, we'll subtract that. And then if the data point is larger than our mean, then we'll take the data point and subtract the mean. This just gives us our distance away from each value. So I've got our mean of 10.9, and I'm going to put my data sets around this 10.9 as my mean. So I've got 9, 4, 36, 3, 10, 6, and 8. It doesn't matter what order you put them in because we are just going to use the calculator then to figure out how far apart each of these numbers are from each other. So if I've got 10.9, I'll start off with 9. 10.9 minus 9, that's going to give us a distance of 1.9. So that means 9 is 1.9 units away from our mean of 10.9. Then I'm going to do 10.9 minus 4 to give us a distance of 6.9. And then 36 is bigger than 10.9, so I'm going to do 36 minus 10.9. So the distance between 36 and 10.9 is 25.1. Then I could do 10.9 minus 3, and the distance between these are 7.9 units. The distance between 10.9 and 10 is 0.9 units. The distance between 10.9 and 6 is 4.9 units. And then the distance between 10.9 and 8 is 2.9 units. So you should have 7 distances here. So we've got 1, 2, 3, 4, 5, 6, 7. We're good. We are now going to find the mean of these distances. So I'm going to say 1.9 plus 6.9 plus 25.1 plus 7.9 plus 0.9 plus 4.9 plus 2.9. So that's 1, 2, 3, 4, 5, 6, 7 distances. and divide it by 7. And this will give us our MAD. So 1.9, and we should get a decimal here because these are, our mean was an approximation anyways, so you should wind up with decimal values. So finding the sum of all these distances in the calculator. I got approximately 7.2. So once we find that mean, the MAD is 7.2. And that is our mean absolute deviation. Let's do one more example together, and then you guys will get to you try. And that will be all that I have for you today. So example 1 says, well, this technically should be example 2, but that's okay. Find the mean absolute deviation, the MAD, for the data set. So the first thing we need to do is find the mean of the data set. So I'm going to take 16 plus 5 plus 1 plus 9 plus 57 plus 35 plus 10. And there are 1, 2, 3, 4, 5, 6, 7 data points again. So when I find that sum in my calculator, I'm just going to divide it by 7. Or you could use your numerator or over denominator button and complete that all in one step in your calculator. And I get a mean of 19. So our mean is now going to go in the center, and our terms are going to go on the outside. So I have a data set or a data point at 16, 1 at 5, 1 at 1, 1 at 9, 1 at 57, 35, and 10. So now I have to find the distance between these data points and the mean of the data set. 19 minus 16 is going to give me 3. 19 minus 5 will give me 14. 19 minus 1 is 18. 19 minus 9 is 10. Then I'm going to do 57 minus 19 to give me a distance of 38. 35 minus 19 will give me a distance of 16. And 19 minus 10 will give me a positive distance of 9. I then can add all these up. So I've got 9 plus 3 plus 14 plus 18 plus 10 plus 38 plus 16. Make sure you have all 7 of these. So 1, 2, 3, 4, 5, 6, 7. And I will divide those by the total number 7. And once again, I'll use my calculator to calculate my mean absolute deviation, or my MAD. I got 108 divided by 7, so that is approximately 15.4. So your mean absolute deviation for this data set is 15.4. That means the distance between each data point is roughly 15.4 units. All right, you guys try the you try.